Hey, hello guys. Welcome to this 11th stream for the OpenHT project. So yeah, today I'm under the impression that I've been saying the same things for a few episodes now. Today what we are gonna try to do is place the at least two shields, one on top of the power supply and one on top of the FPGA. And if we have time, maybe over the RF parts, but I guess we will still have to move a few things around, which we are also gonna do a bit today. So yeah, as you can guess, whenever I try doing something, I open KiCad with you and then just do what I find, and I try to get as much done, but it does not follow all the time what I'm saying and trying to do. So yeah, that's that. Also, I opened the project yesterday and did a few things, including moving down the FPGA by a few millimeters, near the centimeter actually, so that we have some clearance around here. So maybe this can drop down a bit so that we have clearance around it for around the shield, and also we have clearance now to place a shield around the FPGA. It took me a bit of time, and I don't think it would have been some interesting content because that's just plainly basic moving stuff around and so on. Also shuffled things around here to improve the design, placing vias where needed and so on. So yeah, okay. So basically that's not much changed since last time. Oh yeah, one of the main things that changed since last time is this. I connected the battery connector to the fuse, which is a resettable polyfuse, and also I added a P MOSFET right after the fuse to prevent from having, in case there is a reverse polarity. I added a P MOSFET as a reverse polarity protection. I could have used a diode, but it would have induced a higher voltage drop, which I did not like. And also, somebody on Discord, I forgot his username, gave a reference for load switch which includes a reverse polarity protection. Which could be nice because it does have a very, very low voltage drop, I think even lower than a P MOSFET. But yeah, this is not what I was trying to... It was an expensive part, and I would have had to change this again, so... Yeah. So the shield, so I also removed everything from the top layer around this part so that we could add now the shield without having to move more tracks than what we already did. Okay, so hi Wojciech and hi Jay. Are you... Yeah, I guess you are the only two watching the stream maybe. So yeah, it's a small committee today. Anyway, so I think on the schematic I already added the shield, and I think I picked a reference already, which is great. So we just have to have a look at the datasheet of this reference and then create a footprint for it. Alright, so this is the footprint that we will be reproducing today. And so let's open up the footprint editor. And have a look at the libraries that we have. I'm gonna create it under miscellaneous passives. So new footprint, it is an MS338-10F, which is an SMD footprint. Okay. So we have to create a square, but they recommend that we have rounded corners, which I'm not sure. No, yeah, okay, I think it's gonna be easy to do actually. We just need to create. Let me have a look at the datasheet. I'm gonna, so yeah, that's the datasheet, very basic. But I'm gonna place it on my other screen so that I can have a look at both and have large windows too. So yeah, I hope everything goes well in the chat. It's not easy to have a look at the same time at the datasheet and the chat and KiCad. Also, I don't know if I already did that. Yeah, okay. Okay, just Wojciech, you're now a moderator on the YouTube chat, so if you need to moderate anything, I don't know, just do as you want. Okay, datasheet is right here. Okay, so I guess, yeah, it's okay. So it's the corner have a radius of 1.85 millimeters. So let's pick an adequate grid. Okay, like this. And 90 degrees. So now I can copy and paste that. Great. Line width will be 1.5 millimeters. Oh, that's wide. But that's the recommended width. So it's 33.5 millimeters wide, and which is from the middle of the side to the middle of the other side. Okay. Ah, no. Okay, can I move that? Okay, yeah, okay, I can move it and keep it on a grid, aligned with the grid, so that I should be able now to, okay, make 90 degrees angles. Also, I guess this is the center, so I should okay, let's 8.05 minus 16.25 plus, let's say, okay, it should be 30 millimeters high, but what's the distance from here to here? Yeah, 1.85 of course. So that means it's just like this. We should be good. Hey Andy, doing good, and you? So I don't know when you arrived on the stream, but we are doing the footprint for the shield that we are gonna add around the DC converter. Finally, actually placing a shield. Okay. No, no, it's too long. Anyway, we'll fix that. Okay, and this one. Okay, 11.4, and so that is 6.2 minus 33.5 plus. Nope. Okay, that's it. And then this one right here, and so that should be it. So that means that if I go from here to here, why is it 40.9, which is way too much? So that means that I think I did some miscalculations. Anyway, we are gonna fix that. Yeah, why is this 33.5? Nope, nope. Okay, and now height, how much is it? Oh, that's 30. So that's right. This one is okay. Good. Okay. Now I should try to get it centered. That's gonna be annoying. Okay, that's centered in the X direction, and we should be at 15, so I guess I need to move it exactly by 0.1 millimeter in the X direction. Oh, okay, and in the Y direction, sorry. And so 14.9, oh no, it's minus 14.35 and 15 point. Okay, so I need to move it by minus 0.65 millimeters. $15. Okay, that is centered. Yeah, so indeed this part is it's a shield, so basically a metal cover that you place around the components. In our case, it's gonna prevent us from damaging the components on the board, and also it should protect it from the noise and improve the RF, the quality of the signal and so on. Because for the DC converter, the main problem is that it can be quite noisy, and it can if you contaminate the other parts of the system, and for the RF subsystem, then it's gonna be to prevent anything around it from interfering and creating noise in the circuit, in the system, and then of course in the RF signal at the end. Okay, so I forgot about something, which is the fact that this is not a pad. Yes, this is gonna be fun, because I need to create a custom pad. Let's try it. It's gonna be calculations again. Or you know what? Okay, so angle, it's gonna be 90 degrees angle. Start point X, it's gonna be 16.75, and in Y it's gonna be minus 15. Center point is gonna be 75 minus 1.85, and the crap. It's minus 15 minus 1.85. No, or plus. Okay, what does it look like? With a 1.5. Shit. That's not how I wanted it. Huh. Okay, let's try. Okay, let's try something basic. Center point 0, 0. Start point x 0, y 1.85. Minus 1.8. Okay, that's what I want. So now I need to move everything in the x direction by 16.75, and then everything in the y direction by minus 15. Great. Now, new primitive, which is gonna be just a segment. Start point x, it's gonna be minus 16.75 and 16.75. Y is gonna be minus 16.85 minus 16.85 with a 1.5. Great. New primitive segment. Then now it's gonna be 16.75, 16.75, and y is gonna be okay. I think I messed things up already. Not a problem. Okay, we are. Okay, we need to place it, and then we are gonna re-edit it so that we can fix the dimensional errors that we find. Yeah, I think adding the segments is actually easiest part. Oh, nice. Oh, I like this duplicate button. Oh, so nice. So this one, just delete it. And so this one, duplicate, and then I'm gonna move it by minus 33.5, and boom, that's it. Okay. Then transform, I'm gonna move it by x minus 1.85, y 1.85. Oh, great. Transform primitive. Move, I'm gonna move it by x, I want minus 33.5 plus 2 times 1.85, and the rotation of minus 90. No! Ah, yeah, I should have hit duplicate nuts. Okay, that's rotation. It's gonna be 90. Huh? What? Is the rotation from the center of the pad? Really? Anyway, then I need to move it by 33.5, I guess. Nah. Transform. Okay. Duplicate. Interesting. Okay, so that's weird. Because I think it's rotated depending on. Okay, let's hit. Huh? Must solve to a single polygon. Oh, you mean I can't do a... Huh. Okay. Well... Okay, let's then try doing this. Ooh, that's funky. I don't know what I did. I think yeah. Oh, great. No, okay. Okay, let's delete. Yes, I'm discovering things with you, as you can guess. Yeah, at least I have fun. I hope you do too. Okay, so this one. Yeah, discovering KiCad. Oh, okay, yeah. my computer glitches and then add a whole lot of ones. Is it? Ah, crap. What did I miss? Start point. Minus. Minus. Nope. Ah, shit. Okay, I think I need a minus here. And okay, so that means that the center point, the start point is okay, let's try to compute a bit instead of putting random values. Start point, center point, x. It's gonna be and in y it's gonna be start point. It's gonna be this and that, I guess. Yeah. Okay, when I concentrate, it's a whole lot easier. Then start point is gonna be 15. 15 in y and like that. Then center point x, it's gonna be that, and in y it's gonna be that. Except that needs to be that 90 degrees and 1.5. Great. Ah, it should still resolve to a single polygon. Okay, maybe. Okay, we will try moving things around later on too. Then final primitive, it's an arc 2 and its starting point. Then it's gonna be 16.75 and y 15. Center point is gonna be in x 16.75 and in y 90 degrees 1.5. Nah, messed up. It was the last one. Okay, why? Oh, can I just? Nope, no luck. Okay, I think then it's just that the start point is the other side of the arc. Okay, great. Okay, I still cannot finish editing the pad, so what I am gonna do is transform and move everything by 16.75 millimeters. Yes! Perfect. So, okay, the deal was that, yeah, it had to touch the square in the middle. Can I just do that or not? Does it allow me to do? Huh, okay. Yeah, and it does remove the solder mask, so... Okay. Then actually, can I move things by then like this, so that the center of the pad is at the origin, is 0. That would make much more sense. Ah! Yes! Huh? You mean you added a 1 micrometer? What about moving the pad again? And I'm gonna try to make it to move it by, okay, if I edit the pad, and because I don't want 1 micrometer pad to be like a thing to be in the middle, and then maybe doing a few unknown things later on. So I really like, I would prefer if, yeah, no, actually maybe we can just, then moving things back again, or maybe I can just, yeah, okay, yeah, let's, and place that at minus 16.75, so that is centered. Okay, and there is a 1 micrometer pad in the pad, so that's not an issue. Whew. Okay. Also, that means that from here to here, I have my 33.5, great. And from here to here, I have 30 millimeters. Okay, I like that. That's nice. Okay, so, and the shield is 0.3 millimeters wide, so this is much wider than I expected, actually, compared to the thickness of the, yeah, when I say the shield is not, it's made out of a 0.3 millimeter thick material, that's what I mean, not 0.3 millimeter wide, it wouldn't make sense. Okay, Yeah, I know. Okay, let's actually then, because it's complaining, let's make it 1.5 and 1.5. Okay, and so now it's not complaining anymore. Okay. Courtyard. What could I do for the courtyard? Do I need a courtyard? Also, can I make like a hollowed out courtyard? Like, no, not like this, of course. I don't think I'm gonna put a courtyard for this shield, because I think that if I do that, it's gonna complain about having it's gonna interfere with the components placed on the board and complain that it's all clashing and crashing in each other. And already like this, I suspect that it might complain if I have something inside this pad, which we are gonna have to check. So here, let's add a footprint from the M17 MISC passive. It is this. Great. Save. Go to the board and import date. Can I, okay, maybe I can move it like this. Why? I don't want it to be magnetized to some random footprint. Yeah. Okay, it's quite annoying. Okay, so this needs to move this way. Okay, let's trying to keep it aligned and move it on one axis only, which can be a challenge sometimes. Okay. just checking. Okay, if there is yes, okay, I'm just checking the changelog of the latest KiCad version. I think I might need to update it. Yeah, I'm gonna do that maybe later on. Maybe not do that right now, but there are a few behaviors which I don't understand. Okay, so these along with this, it does need to move. Like so. This goes here. Rebuild, refill the zones. Okay, great. And this needs to move to here. Okay, so this is now correct. This via, I'm gonna move it here. Great. Okay, the connection between the pad and the ground plane is strange. How would could I modify that? Pad connection. Ah, yes, that's what I thought it would do. So this is not a good idea. Okay, great. Then I think that's basically it. Oh no, this. Okay, so here is. Okay, we have some clearance. I think it's good enough. Yeah, checking the clearance everywhere to be sure that we are good. Okay, that's nice. This, it does need to move. It's a 1.8 volt test point, and I don't think there is anywhere else I could place it. So maybe I can. Okay, modify this track, and so now I should have. Okay. I'm gonna get it as close as possible from this component because I don't want my test point to be too close to the shield. Otherwise, I am afraid that that we could touch the shield while probing the point, which I would like to avoid. Okay. So this, let's move that, put it here. I guess this will need to move. So that this plane is not broken. Okay, nice. Let's make a bit of room around the ground pad. Yeah, okay. Okay, it's gonna improve a bit the thermals of this pad so that it's connected on the 4 sides. Okay, so I think that's pretty much one shield done, actually. So I can remove that. So now if I have a look at the 3D viewer, no, I need to, this is gonna clash. This is not good, but I have now some room to move it down a bit. This is good. I'm gonna just fix that, and yeah, fix that too, maybe. Okay. I don't want it to be connected via the thermal relief because I don't like it. It's not done as I would like. So let's just add some track ourselves. Okay. Oh, that's very not good. How can I prevent the track from starting right here, which is really not what I want? Okay, let's have a look in the settings. Ah, that's it. Never snap to pads. So it's just to be sure. Okay, so now, haha, great. What? No! Please, no! What the hell? Am I gonna have to like create a track all around it and then do the routing? It's not supposed to do that. Okay, let's stop all snapping. Okay, it's annoying. If I do that, what does it do? Yeah, of course. And I can't set okay, let's already move this. I know that it's an issue for now, so that we know we have to do. And now I have to restore snapping. Oh, it doesn't snap? Okay, I thought it would snap to the track below. Anyway, I can even move that down to here, like that. I can even actually move that down. I can actually even, yeah, okay, let's move that and use it as a V actually. So what did I, okay, 0.25. Okay. Great. Oh yeah, this also. Oh yeah, maybe I can connect the shield via some vias. Let me think. I think that would be feasible. And let's pick. Okay. Okay, I can. And now under your eyes, I'm gonna make this via disappear. What the hell? Okay, great. Maybe I can. Oh yeah, I guess it won't work, of course. Or will it? Oh. It did work. Okay, unexpectedly. Let's remove the vias which are in the way. Oh, this one is almost perfectly well placed. Well, let's move that a bit. And can I move all of them by just a bit so that it fits in between the two tracks? Nope. Yes, I can. Okay. Oh no, this one doesn't, but it's not a problem. You can remove it. Okay, Great, so we have some vias in the footprint of the shield. Okay, 1 hour of stream already. Maybe I'm gonna do a short break. Try to see if I can update KiCad and brew a cup of tea maybe. So let's save that. And yeah, okay, I'm gonna catch you in a few minutes when everything is ready. See you guys. Okay, welcome back. So KiCad have been updated and I have my cup of tea. So let's get going. Okay, let's just check that we are indeed, yes, on the 7.0.2 version. Great. And okay. PCB. Oh, maybe can we, now that we have some vias? Oh yes, that's it. So now we can drag tracks from the vias to the ground planes around it. That's perfect. This. Okay, that's a bit tedious, but yeah, that's part of the process. Okay, except that what is it trying to make me do now? Nah. Hey, come on. Okay, that's very finicky. Come on. Okay, that's not perfect. Oh yeah, but I guess I have freezes at the same time, which is preventing me from doing everything I need properly. Okay, so you have to kind of make a small dance with your mouse so that you get it untwisted. KiCad, always at the verge of reality. When your track is twisted, you have to untwist it with your mouse, like a small swoop, using your little hands, and so on. Oh, come on. Yeah, okay. That's it. Come on. Okay, great. Come on. Ah, no. Fucked up. Ah, please. Okay. Come on. Okay. Ah, I twisted it too far. Okay, great. Okay, great. So now just add a few vias on this side and this side, and I guess we should be good. Okay. Maybe this later on after this stream, off camera, I'm gonna try to create the shield, see what I can do with FreeCAD, if I can make it easily. Otherwise, I guess I'm just gonna ask you, Jay, if you are still listening, if you can make it, if I can't make it, let's say, quickly enough. But I would like to try, because I would really like to try what FreeCAD is like now. Okay, let's okay. The allocation violates the RC. Yes, I know. Okay, then we are gonna skip this one. This one is gonna violate the RC too, so let's skip it. This one is gonna skip. Yeah, it's not gonna like it either. So let's. This one is good. And I'm gonna move everything down. Ah, come on. Move everything down a bit. Oh, good. I'm getting angry at this computer. Let's move things. This should be just what we need. Gonna remove that one, it's in the way. And then let's try to copy paste it to the other side. I went too far, did I? Okay, I guess it's still... Yeah, okay, just keep it like this. And paste it. Then we are gonna have to add a few vias. The one that we didn't place on the other side. This one needs to go. This one is perfectly placed. Oh, this one too. Nice. This one. Wow! This one is almost perfectly not in the good place. And then one more. Okay, let's do our dance and connect
the vias to yeah, I'm thinking about if we really need to do all this. I don't actually think that we need to do that, especially if we have already all the vias going to the ground planes. Let's see. Yeah, okay, I think I'm gonna... Okay, I'm gonna place it. It's easier to remove it anyway if I really want to, so let's do it. Come on. Okay. Why? God, there is some kind of latency that's preventing me from placing a track every now and then. Now I guess the dance begins. I have to untwist. Yeah, okay. Come on, freeze. And now on this side. Come on. Okay. Okay. Like that, perfect. Nope, this one isn't complete. Okay. And why is this one going all the way down? Wait. Trying to stay calm. It seems that if I zoom more, it's not so difficult to place. Trying to stay calm while KiCad is refocusing the view on the center of the on what it considers to be the center of the pad. that's one shield done. So yeah, I don't know who is still watching, but yeah, that's one shield down, done, and two more to go. That board is coming on great. Yeah, yeah, that board can be kind of boring sometimes. I agree. The board is not boring, but I mean, the steps to do it can, I guess they are not all very fun to watch. Okay, seeing that it's already past 10 p.m. here in Belgium, and I've been streaming for an hour and a half already, I'm just gonna try to get the next two areas ready for their shields too, but I'm not gonna have a look for the shields today. I'm gonna do that off camera, and then we are gonna place them together, I guess. The inductors, no, I didn't. Yes, I'm gonna do that now. So that's this one that you designed, if I remember correctly. And so yeah, this is the one that I'm gonna place. Ah, did the audio really? Okay, yes, okay, audio's. It was going great. Why did it do that now? Okay, so pay attention to your ears. Okay, so the audio should be correct now. Oh. I'm missing a spoon for my tea. Just a second. Oh, the mic didn't like that. It was all red. Yeah, placing the inductor that you designed, Jay. I'm gonna go to the conversation that we have and download it. So I have the FreeCAD source file and the step file. Great. Footprint editor. Which was in M70. Oh, yeah, I think there was a problem with that one. The one that I have. No, let's have a look from the schematic instead. So that's the one. Yeah, okay, so it's the inductor from the KiCad library. I think I'm gonna copy it and as your model then. Or maybe what you... Yeah, I don't know how... If KiCad accepts like just pull request for 3D models and so on. I have absolutely no idea. So let's just drink. And I think I'm gonna, okay, just I need to copy the reference to know which one I'm. Tau Juden. Tau Juden, yeah. Taiyo Juden NR50. Taiyo Juden NR50, like that. Copy the footprints, and then M17 misclassives, paste footprint. Great. And now we just need 2 3D models. Remove that one, it doesn't exist, and I think I need to, yeah, rotate it. Nope, that's the offset. Nope. Yeah, perfect. And so that is exactly what we need. Except that also I need to place it alongside the footprint, so that would be in the Git repository. Here, here, and here. Okay, and then it would be like that. So now I need to update the footprint from here to select one from M17 KiCad library. Excellent. Update. And now, yeah, great. Look at that. Oh, I don't know what I did, but I sure did something. Okay, this board is really starting to look like something great. I actually like what is happening now. Yeah, I wanted to also create the QFNs, but I really do believe that KiCad does have Python script that generates the QFN or something like that. Oh, actually, you're right, Jay. I'm gonna. Oh, except that. Okay, I think I'm gonna exploit a feature of KiCad to, because I don't know if they allow that. Okay. Can I have a new footprint? No, I can't do that. Because I think that the NR50 is for the XY dimensions of the footprints, but we are using an NR50-30, and 30 is for the height. So that means that the 3D model is only valid for the NR50-30. And I wanted to do like for the components where you can have several versions of the same footprints. So maybe I'm just gonna rename it 5030. And so we have the 3D model on it, which is 3 millimeters high, and so that should be good. And then I'm also yeah, maybe I can general 5030, 5030, 5030. Okay. And did it rename it in the... Yes, okay. Just then name the step file and FreeCAD files accordingly. So that means that I have to modify that like this. I need to go... Okay, what's happening? Oh, I can't do anything. Okay. Okay, I had a massive freeze. It seems that... Okay, yeah, everything is back on track. Maybe there was a glitch in the stream. Yeah, okay. So I said I need to go back in the schematic and update the... Oh, I'm getting a lot of warnings from YouTube, but it seems to be right. Yeah, okay, let's discard it. Okay, okay. Import. View 3D viewer. Great, okay. So, yeah, good, nice. So yeah, I don't think I have much more to do in this area. Except maybe place a few vias here, where it seems to have been forgotten a bit. Why is this one connected via a solid from parent footprint pad shape? Yeah, okay. Use zone settings. What did I select for the zone? Thermal reliefs. Why is it a solid connection to ground? What did I do? Hey, I realized that only now, but how is it that I have solid connections to ground, but only below the shield? Huh? Wait. No, okay, no, this is another ground plane, I guess. Yeah, this one too is connected. That's so weird. I don't get it. It would seem like a bug to me. So if I... Okay. If I delete the shield, can I just delete the footprint? Okay, and then I... Yeah! It seems like we discovered a bug. Huh. That was unexpected. So if I restore the footprint of the shield, then yeah, all my pads have a solid connection to ground. That's suspicious. Also, that would need to be fixed at some point. I don't know. I don't like these connections. How is the stream going? Because YouTube is warning me that the stream quality is poor. What do you say? Okay, I guess one of the easiest solutions would be to create a fill area that we are gonna place here, just under the shield with thermal release. Audio glitches. Oh, okay. I really have no idea if my mic is being all buggy and doing annoying things, or if it's like from OBS, which is a bit finicky, or the graphic card. It's all very strange. Okay, except that I need to... What is the priority of this one? It's priority 1. So I need to have a priority of 1, 2. And then it fixes the problem. Except that maybe this is too much for the width of the thermal via. What are the defaults on that? It can't do that. Anyway, let's use 0.3. No, let's wait. Okay. Oh, that's an ugly fill. Priority is 1, 2. I need to up that. And I think actually I would rather have, nope, not this. Have this. Let's reselect an imperial grid. I guess this is gonna screw up everything. Okay, so ground paths are corrected as expected. Oh, this also needs to be increased by 1, I guess. How high is this one? 1, okay. Do I have other planes that I need to fix? This one is 3. This one seems to be correct too. That's good, that's good. Okay. Okay, let's go to the FPGA now. So regarding the vias, everything should be good already. However, we can move a few tracks around to improve things. Whoa. Okay, so having ground all around the vias and so on, it's not mandatory. And usually if you look at very dense circuits, they don't take this much care of that. But in this board, we have plenty of room available, so let's just use it carefully. And yeah, that's pretty much it. Can we maybe move that one here? That one is a bit too close. Oh, why did my... Okay, I guess I'm not gonna be much longer because everything is going wrong on this computer. Now my mouse is being much faster than usual. I have no idea what's happening, but it's very annoying. This ground via is useless. Okay. Yeah, okay, this is where it becomes very messy. I wanted to have ground initially going there, but I don't think I'm gonna go into this much trouble of trying to have it. So let's just do that. Because I also need, I also need to think about the shield that's gonna come here. And around here I have too many vias and so on, so it's gonna prevent me from having the shield being placed easily, and I don't want that. So let's try to gather the vias so that it won't be an issue. So that means that I do that. So this one goes down, and hey, it goes down. Here and here. I guess there is a way to improve that. So let's remove this. Okay, and then pick it up about here and try to route that in a better way. So yeah, maybe even pick it up here. And then go on the top. And then like that. Okay, I'm gonna need to add some ground vias here. So that means that I'm gonna have to move these tracks around. So that I can place a via here. Oh, maybe can I... Can I maybe... Okay, like this. And even move this via right. This, just move it like that. So I can move that like this. And have this here. Okay. Also ground vias here for the crystal oscillator TCXO. Okay, great. And I still have this track, which I actually could, so if I move that over here, and that like so, I can move that like this. Oh yeah, but so I can actually move that up a bit and maybe use the test point, the test point as a via once again. So it's gonna allow us to move the test points out of the way. Like so. Okay, great. And so, yeah, right here we have, could this be moved a bit or not? I actually think that this doesn't need to be that wide. So if we make it a bit thinner, then we can move that. This too. So this one can move. And okay, great. And yeah, this track at some point is gonna have to go below the shield, and I don't know how I'm gonna do that yet, so let's not do that now. Okay, so yeah, we can see that there is a bounding box that we can draw that encompasses all the FPGA and its surrounding components, so that's nice. Okay, even though the FPGA is not the most critical part that needs a shield, it's mostly gonna be for protection against what we could inflict on this board while we show it around and so on. However, this is gonna benefit from having shield around, I guess. No, connection missing ground here. Can fix that later on. Okay, I think I'm gonna leave it here for today. Hope you enjoyed. Shield out of transparent aluminum. Would be nice. I don't have this material in stock, sadly. We could make it out of glass, but then it would lose its shielding property. Is there a material that could be used as a shield and is transparent? That would be very nice, but I don't think there is. Anyway, let me wish you a good night for those in Europe, or a good day for everybody else, basically. Hope you enjoyed today's stream. I am sure happy that I was finally able to place the first shield. So I don't think we are gonna need to go over here a lot. Maybe I'm gonna do a few things off camera again, like also picking the references for the shields that we are gonna use here. That I'm probably gonna do it off camera. Anyway, thank you very much. 73s to everybody, and I'm gonna catch you in the next stream, or on Discord maybe.